We're interested in the area underneath y equals x squared between x equals 1 and 1.5. We're going to use rectangles with a width of 0.1 to find lower and upper bounds, essentially. So first of all, the lower bound is going to be when we use the smaller rectangle. So this rectangle here, for example, will be 1 squared times 0.1. And if I add it to this one, that would be 1.1 squared times 0.1, because the height is in line with the 1.1. And what I can do is I can just add all of these up, to be honest, and then times by 0.1 at the end. We're going to go all the way up to 1.4, because that's this bit here. Okay, and ignore the 1.5. Times it all by 0.1, and it does equal 0.73. Like, it's worth putting in your calculator. Maybe this is only 1 mark. It's almost like just trying to guide us, to be honest. Then the upper bound is very similar, but we're going to use the right-hand point. So the first term will actually be 1.1 squared. This time we will include the 1.5 squared as our highest, because we want all these rectangles here. Times that by 0.1, and that will equal, as they've said in the question, but do feel free to check, 0.855. So we found the lower and upper bounds for the area. In part B, Alex uses smaller and smaller widths to investigate this problem, so many more rectangles to consider, and the lower and upper bounds are given. We're asked to use Alex's results to estimate the actual value of A to correct to two significant figures. So as the rectangles become smaller, they're going to give a more accurate answer, first of all. If we split it into two, for example, then there's just going to be less area that's missed, because you can see we're sort of going above, and so this is what it would look like for 2 for the lower bound. So basically this one here will give the most accurate answer. We've got a lower bound, we've got an upper bound, so a good estimate would be to say that it's 0.79. Because we can see it's more than 0.78, but it's less than 0.8. So 0.79 seems to be the one to go with. We don't know for sure whether it might round up to 0.8 maybe, but yeah, this is a good answer. Give a brief justification. Well, it's essentially halfway in between. If you take in 0.784 and add 0.799, but basically find the mean, then this actually gives, I've done this one earlier, it's 0.7915. So the upper bound is overestimating. We get these extra bits. The lower bound is underestimating. We can sort of see that the gaps are very similar. So that is definitely a good justification for why it's 0.79. Finally, we're asked to write down an expression in terms of y and delta x for the exact value of the area A. So although we tend to say that an integral is f of x dx and we integrate it, sort of forgets what we're actually doing. In fact, we are doing a sum of f of x times delta x. But that's what's happening when you have these rectangles. We're summing up lots of small rectangles. Now, the function is changing as we go along. So I'm going to put a little I here to indicate that this is like a discrete process. And I is going to start at 1, and technically it goes to infinity. We sum an infinite number of infinitesimal rectangles, which means we also need to have the fact that the limit of delta x is going to approach 0. And that is that is it. And then that actually becomes this thing over here. But this is what is wanted now. Although I say that, it does say in terms of y, so I should probably change f of xi to yi. Now the mark scheme does it slightly differently, and I'm not entirely happy with it. It does very similar with the limits, but then it goes from x equals 1 to 1.5. Okay, I can see why it's doing that. But what I don't like about it is that when you have summation notation, you always go up by one every time. So how can we start at 1 and go to 1.5? The really the I equals 1 for me is identifying just the first value, and I just need to make sure that it is at when x is equal to 1 and that the last value is at 1.5. Um, X squared is allowed instead of y. You're not allowed to just write 1 to 1.5. You have to write x equals. So I'm sticking with mine. It's because I don't really like this, but this is what the mark scheme says. So I suppose it's worth paying attention to as well.